this section is entitled Application Lifecycle Management, Know Various Ways to Configure Applications. This is essentially a continuation of the previous video where we explored the theory around various states of pods and their containers, right? And this time we're going to go through the same thing again, but maybe more visually and with more concrete examples. So the first scenario we're going to consider is the scenario where there are, for example, there's no nodes, and so the pod cannot be scheduled. I did this by going to my EC2 management tool to the auto-scaling group and just scaled down my nodes to 0. And you can see indeed that I have no nodes that can run my pods, right? So what I'm going to do is I'm going to just run the example that I had done earlier, which is, let me just look at it real quick. So this is basically in this project I've got a not scheduled folder, and in there I have the example, which is basically the same example we used previously with a perfectly valid pod and container with Ubuntu in it, right? But if I try to run this, so if I will do helm install dev, and this is not scheduled, and it'll attempt to create the pod, and it's going to try, the scheduler is going to try to schedule it. But if I do, first of all, I'm going to do a couple commands here. I'm going to do kube control get pods, and you see it's pending, okay? I'm going to also do kube control describe pod. Now I could type in example dev, but I'm going to be lazy for the video for expediency. I'm just not going to provide the name of the pod, in which case I'll do all the pods, but there's only one pod, so it's the same thing as doing the one pod. Let's look at the details here. So first of all, you can see that this pod has a status of pending, right? And if you look at the container, it is in a state of, slow down. The status of pending, the conditions basically say that the pod is scheduled as false, and then it gives you the reason in the events is no nodes available to schedule pods, right? That's pretty much all information we get, and there's not a whole bunch about the container itself, mostly because the container doesn't exist yet. So if you look at the diagram here, you'll see the pod phase is pending, right? And then the pod conditions is it's scheduled, and there's no information about the container or any of the other conditions. So that's probably the easiest example. So we're going to go to the next example. Now, in order to do the next example, I need to go back into my auto-scaling group and bump it back to one node, or two nodes for that matter. So I'm going to pause the video, bring up my node, and then we'll restart. Okay, we're back. So I already did a couple things while the video was off. One was I turned on the nodes, right? So I have my node back. And I also uninstalled the last example because we want to look at a different example. Okay, now in this example, there's a little bit of theory before we get into it. So far, we've been only talking about just plain containers, which are kind of carrying your workload, right? Kind of your web app or your application, right? Now, there's another concept called init containers, and they're separate, and they're essentially designed, there's some constraints around them. So essentially, you should think of them as basically, they start before your other containers, and they launch in order. So if you have 2 or 3 containers, they run one after each other, and they won't continue the next one until the previous one finishes. And then it also implies that the containers need to run to completion. So there you go. Conceptually, you're trying to let them terminate in a succeeded state so they can continue on. If one fails, it pretty much kills the process and it restarts again. So that's what init containers are. They're initializing your pod. And that's what we're going to look at. So we're going to have a situation where we have, and then the final result is kind of, I'm going to diagram here. So we'll have a container that has an initializing, a init container that fails, right? And so what's going to happen is the pod is going to bring up the pending, and it'll get scheduled because my node's not running, right? But you'll notice that it won't become initialized the container is not going to be ready, and the pod itself is not going to be ready. You'll notice that I called it I1. The initialization container, init container 1, will be in a waiting state, as well as your main container, and the main container will not be ready either. So let's look at running this and confirm all this aspect in the output. So let's look to see how I created this container first. So this is not initialized, is what we're looking at here. So you'll see there's lots of examples we got here. So this will take a while. But in this example, I've got my main container the same as before. So it's a perfectly valid container. But you notice I have an init container called I1, and the image itself is bogus. So this is an image that doesn't exist. So this init container should try to download this container and then immediately fail. And then just this whole thing is kind of stuck in the loop. Okay, so let's validate this. Right. So I'm going to do helm install not initialized. Oh, I forgot to put dev here. Okay, so let's let this start up. It should be running any second. Okay, and if I do, we'll just do all the various commands. We'll do kube control get pods. Okay, well actually no, interesting enough, the status here is a little more informational. It says init error pull image. If I do get describe pod, let's see what it says there. Let's look at all the details here. So the status of the pod itself actually is still pending. So that previous message was being helpful, right? It was kind of giving more information, but the actual status is pending for the pod itself. Okay, that's expected. And then we want to look at the various conditions. You see it's initialized is false, right? Well, let me see. The order here should be pod is scheduled is true, because now it's scheduled at least, but it's not initialized, it's not ready, and the containers are not ready, right? And then in terms of the container itself, we'll see that container 1 is nothing going on. It's basically waiting, and it's false, right? Because it can't do anything yet. That's because the first container, which is a init container, I1, it is also waiting and false, and it gives you more information about why it's waiting. Image pull back off. And then the last piece of this puzzle is, if you look at the log, you will notice that it cannot find the repository called bogus, and it tells you exactly why it was failing. Okay, so what we just saw in somewhat detail, but was essentially these various states here. Pod phase pending, pod is scheduled, not initialized, containers are not ready, the pod itself is not ready, and the containers themselves are both in waiting, and the other containers not ready. I mean, both their states are waiting and then it's not ready. Okay. Whew. Okay, so let's take that container out. Okay, so I'm going to do helm uninstall dev. This should take it out. Let's look at the next example. The next example is, it's very similar to the previous example. I just wanted to show another reason why that init container can fail. In this case, I'm going to supply it a bad command, so let's look at it. Let's look at it. So it's called not initialize 2, and it is templates. Okay, so this is the same. The primary container is the same, and I actually use a valid image in Ubuntu, but the command I pass to it is bogus. So it's a valid image, but a bad command. Okay, so it turns out that it's going to have the same in terms of the various outputs. We're going to see exactly the same statuses here, right? The only difference is we're going to see some more details in the event log that's going to tell us different information. So let's look at this one real quick, and then move on. So I'm going to do helm install not initialized 2. Keep on. Maybe I'll eventually get this right. Okay, so let's let this one start up. and look at the output. So if I do kube control get pods, now it says init run container error, but if I look at the detail, kube control describe pod, we'll get even more information here, right? We're going to get, I'm going to walk through the whole thing each time. So we have the status is pending of the container, of the pod. Okay, that's good. And then the various conditions, right? Everything is false except for pod is scheduled. Okay, that's expected. And then at the container level, container 1, nothing's going on yet. It's basically still waiting false. And then the container in question, our init container, it's in a state of waiting, right? And it tells you the reason, run container error, right? And then there's more detail in the message here, right? And then, of course, you can look at the log, and it says, failed to start container, basically could not find the command bogus. Okay, so that's expected. Okay, so I think that's that example. Let me think. We are on non-initialized. Okay, so we're now down to another example. Let me pause for a second so I'm going to turn everything off and get it ready for the next one. Hang on. I'm back. So this time we're going to do something a little different. We're going to actually introduce a second initialization container. So we're going to let the first one succeed, and then we're going to fail on the second one, just to see what that looks like. Otherwise, it's the exact the main primary container is still exactly the same. So let's look at the code. This is now not initialized 3. Here it is right here. Templates, an example. Okay, so what's going on here? We got the main container is the same. We've now got a valid first container, right? It says echo hello, so that's a valid command. And we put bogus on the second one. And just for reference, the name here, ix, x is supposed to be to represent the second one, or arbitrary the xth one, so, or nth one, right? So this one will fail. So let's try running the command now and see what this does. So this is going to be helm install. Which version was this now? I'm already lost track of myself. This is under not initialized 3. Not dev, not initialized 3. Okay. And then let's look at the output here. Okay, so if I do kube control get pods, okay, it shows up the same init run container error, right? And then if I do kube control get describe pod, let's look at all the details here. Oh, and I didn't look at the diagram carefully. Let's step back for a second. Let's see what we are expecting here. The diagram basically says the pod will still be scheduled, everything else will be false. The first initial container will actually be in a terminated state with success, but the second one will basically be waiting, and everything else is now waiting, right? So if we look at the output, let's see if we see that. Status is pending for the pod, okay, that's expected. The various conditions, right? Pods are scheduled, but everything else is still false. Okay, that's good. The primary container, C1, is still waiting, right? You can see that the first container, I1, terminated with a success code of 0, exits 0 success. But the second one is now pending. It's not pending, it's waiting, and it's got a run container error, and it's terminated. No, it's not terminated. It's actually waiting and not, it's basically waiting. It's basically keep on trying, right? And then the details down here saying, basically describing, hey, there's a problem, couldn't start the container because a bogus was not unknown command. Okay, so again, that was expected. So let's get rid of this one. Helm uninstall dev. Okay. Okay, let's continue on. Okay, so I'm going to change gears a little bit. We're going to, what do we have here? We're going to switch now to having the init containers be valid. So if you look down here, you'll notice that I1 and IX both will terminate properly. But we're going to provide a bad image to the primary container. Okay? And what we see is the one big difference here is that you'll notice that in terms of conditions, you'll notice it's now initialized, right? Because the two containers initialized. But then everything else is essentially back to being it's still going to be a pending state up here. It's going to be false, false, and then the container itself will be waiting, and ready won't be false. Okay, so let's watch what happens here. Well, let's actually look at the code first. So this was not. We're into the container examples now. Not container ready templates. And you'll notice here now the two init containers are both valid. They both echo hello. But now I've got the bogus image on the container itself. Okay, so let's just run this one. Helm. This is a little bit tedious, but install dev. What example is this? This is the not container ready. Okay, so then we go kube control get nodes, not nodes, get pods. And it says error image pull. Before it had the init in front of it, now it just says error image pull. But if I look at the actual status, kube control describe pod. So the actual real status, right, is not that. The actual status is pending, right? Okay, that's expected. In terms of the conditions, kind of next level of status, right? You can see that it's now initialized. It's pod scheduled and it's initialized, but other things are false. Okay, that was true with the diagram. And then looking at the container level, you can see that both, let's see if I can find them here, both I1 is terminated to a completion of success, and IX is terminated to a completed status of success, 0. So that's good. And then you'll notice the container itself, it's basically an image. It's in a state waiting, and it's not ready, and the details are in the logs, right? Basically cannot pull this. Okay, so that's that one. So let's get rid of this one. Helm uninstall dev, and let's go to the next example. Okay. Now, if you look at these two examples here, it sounds like they're almost identical. So this example is I'm giving a bad image to the container, and you'll notice that the phase still shows pending, right? But this time I'm passing a bad command, so it's a valid container, but it's a bad command. And the main difference here is now the pod phase will actually be now running. And running basically means that all the containers have at least been created. It doesn't mean that they're successful. It just means that they're created. So that's where this pod phase can be super misleading, because it'll say running, but it's not really, things are still not right. What we're going to see is that the state will still be waiting for the for the container, and it's not going to be ready. And in terms of the conditions, you'll see that the containers are not ready, and itself is not ready. So let's just roll this out. Let's look at the example first. So this one is not container ready 2. And here we go to templates. Close this one down. So the way I broke this one is the container itself. It's a valid image, but an invalid command. Okay, so pretty straightforward. And let's see the outcome here. So if I do kube control, no, not that, helm install dev not container ready 2. And let's look at the status of this thing. So if I do kube control get pods, if I spelled it right. So here it says, the status says run container error, right? But if I go kube control describe pod, let's see what's going on here. Go way to the top. Right, so the actual status, again, the other status was more of a helpful hint, right, to give you some clue that something was wrong, but the actual status or the phase is actually running now. So if you look here, you might be tempted to think everything was looking okay. But if you go down to your conditions, right, you notice that your pod is scheduled, it's initialized, but the containers are still not ready, which means it's not ready, right? And then if you look at the actual problem, you can look at the container. The two init containers are good. This container is still waiting, and it's not ready. And it says run container error, and of course you can look at the logs and see the error. Okay, so that's that example. Let's get rid of this. Helm uninstall dev, and let's look at the next example. Okay, the next example here, we're going to introduce a new concept, and then we'll look at the example. So the concept is the containers themselves have a, give me a second, I'm going to pause the video for a second, and then I'll be back. Okay, we're back. Actually, I can't remember where I ended up at, but one of the things we'll look at is a new theory that we need to cover here before we go through this example. So there's a concept of lifecycle hooks inside of the containers themselves. So there's two in particular, one called pod start and one called pre-stop. So basically the first one is every time the container itself is basically, first it gets created essentially, you have the option to run a basically command after that. That's called pod start. There's also a pre-stop one, which is basically, it's called right before a container is terminated. But we're going to only mess around with pod start. So the example is, and I added this one afterwards because I forgot about it. So that's why it's called 2-5. So this template looks like, so now so we're focused on the container. So the container now is going to be fully working, right? But we're going to give it a lifecycle pod start, and we're going to execute something that will fail. And we'll see what that looks like, right? And the end result's going to be, you're going to basically have the same scenario where you're going to see that the pod phase will be running, but the container will not be ready, which means the pod's container conditions will not be ready either. So let's look at this one. So let's run it. So if I do kube control, no. If I do helm install dev, not container ready 2-5. Okay. So let's look to see what the output of this one looks like. If I do kube control get pods, it's going to say the pod is initializing, right? And it's still initializing. It's going to get stuck initializing. But if I actually look at the actual, so if I do kube control get describe pod, we get more detail, right? So we will get, so we'll see, start at the top. Let's see. Actually, the status is pending. I'm trying to think. I was actually unexpected. This was, yeah. Okay, well, I might have to update my diagram apparently, because in this case, the pod, let me look one more time. Oh no, it just took a second. Okay, so I was confusing myself. Let me just clear this again. Describe pod, and the pod is running, right? Now this, interesting. This may actually change status depending on where it's cycling. I was expecting always to say running. So the pod is primarily running. And then if you look at the conditions, you'll see the pod is scheduled, it's initialized, but it's not ready, and the containers are not ready, which means it's not ready. And if you look at the detail, you will see that the container itself, it's basically in a state of waiting. It's showing waiting, it's not ready. And then the detail is essentially talking about the lifecycle hook in C1 is basically failing with the command bogus. Okay, so that's pretty much what we expected from the diagram. So it's basically the same diagram, it's just different reason for failing. Okay, so now we're going to introduce another set of concepts. So let me stop this. Helm uninstall dev. Let that play out. Okay. So the next concept we're going to talk about is probes. So once your container is up and running, so what we're going to do is we're going to get to the point where the container, if you look down here, you'll see the container is actually going to be running, but it will not be ready, right? So this is illustrating the fact that just because a container is running doesn't necessarily mean it's ready to be used, right? And what differentiates these two states is this concept of probes. So essentially, let me see if I get this right. Basically, a probe is a command, right, that's going to perform some diagnostic on your container before it decides it's in a good shape. And so there's different kinds of executions you can do to do the probe. One is you can run an executable, and that's what we're going to end up doing. But you can also do things like make a TCP socket open. So you can open up a socket, and if the socket opens, then somehow your container is considered to be fine. Or you can do an HTTP GET action. So you can hit some endpoint on your inside your container, and say it's a web container, to validate that it's in a good shape. So that's kind of the action. Now there's actually 3 different kinds of probes that you can run. And this, I'll walk him through real quickly. One is called the Liveliness Probe. Essentially, it's deciding is your container, it basically decides whether your container is running, right? And if the probe decides to fail, if it fails, it's going to basically kill your container and cause it to restart. So liveliness is trying to essentially decide if your container is crashed. A readiness probe is a little different. It's basically saying, hey, is your container ready to be operational? Is it ready to be used? And the distinction is you're not checking necessarily whether it's crashed. You're just deciding whether it's ready to be used. Maybe your container depends on a database that maybe the container is fine, but the database that depends on is not running. And so you want to not allow it to be ready until some external dependency is running. So the difference here is that if this readiness probe fails, it does not crash your container or kill your container. It leaves the container running, but leaves your container in a not ready state, essentially. The third example is called startup, and that's the one we're going to use, by the way. Startup probe is it's a newer one, and it's really kind of a lot like the liveliness probe in the sense that if your container is not in good shape, it's going to basically kill it, right? It's basically the way you should think about it. It's basically the same as the liveliness probe, but only used at startup. And that way you can adjust some of the timing around it. So I'll leave it at that. And then the key thing here, though, is that the liveliness and readiness probes, they live forever. So if later on your app fails, it will then take appropriate action. So startup is only at startup, and the other two are used perpetually throughout the life of the container. A lot of details in here. I'll breeze through them quickly, I guess. So there's some other parameters around these probes, and they're pretty self-explanatory. For example, initial delay seconds says how long do you want to wait before you actually check something, right? So maybe you don't want to start right at second 0. You might want to wait like 10 seconds or something like that, right? Period seconds is how frequently are you going to, on the first two probes, right, that happen perpetually, you want to know how often do I want to check. Timeout seconds is how long it takes before, if you call the probe and you don't get a response in a certain amount of time, you might decide that that's not a good thing either, right? So there's a timeout on the probe itself. And then success threshold is, if I understand it right, if your container's already decided to be failed, say that the readiness fails, right, and it's not ready, you want to maybe wait for a certain amount of tries before you decide that your container is ready to be, maybe it has to have so many successes before you decide that, okay, it's really ready, it's not like oscillating. And then failure threshold is how many failures in a row are you expecting before you really decide that there's a failure. So you can adjust that. Okay, so a lot of knobs there, okay? So the example we're going to do here is we're going to have everything start up fine. We'll have our initialization start up fine. We have the container will actually start up fine. It'll be running. But we're going to fail deliberately the readiness probe, in which case it'll never be ready, which then means now my containers are not going to be ready, and then thus the pod's not going to be ready. Okay? Now, if you look at the example here, excuse me. Templates. Hey, give me a second. I'm going to get a glass of water for a second. I'll be back in a second. Okay, I'm back. Okay, so the example here is I'm going to have the two successful init containers. I have a successful container, right? The command's fine. But I've got a bogus command as the readiness probe, so this will always fail, right? And to illustrate this, I do helm. I'll make sure I don't have it running still. Okay, I don't have anything. Helm, install, dev, and then this is, which one's this one? This is not container ready 3, not container ready 3. Okay. So let's see what this one says. If I do kube control get nodes. Okay, so now, interesting enough, it says the status is ready, which is what we're expecting, right? We're really expecting the pod, actually the pod phase is ready, right? No, it actually should be running, interesting. Well, let's look this, I'm curious now. What I really care about is what this says. Describe nodes, node. Okay, let's look at the actual status, or the phase. And the phase here, where is this thing? Okay, there's so much detail. Okay, here it is. Where did I just, hang on. Okay, hang on. Oh, it's not node. Okay, I was like looking at something that didn't make any sense to me. Okay, now it makes sense. So yeah, the status is actually running, which is interesting. So here the status really is running, and the diagram should say running, right? But now I'm curious. I'm going to go back. I'm going to get, oh, I know what's wrong. Okay, I think I was using node. So the status is running. Okay, that's what I expected. So what's a little deceptive here, right? It says running, and I'm going to think, oh, everything's fine. But when I go to describe the pod, what in the world? Oh, yeah, this is right. If I describe the pod, let's look at more detail. I'll see it's running, but when I look at the conditions, its status is initialized, it's scheduled, but it's really not ready yet, right? The pod is not, the containers are not ready, and it's not ready. So it's running, but it's not ready, right? So that's the important distinction here again. And then if you look at the containers themselves, you will notice that it's basically the state is running, so the container itself is actually running, but it's not ready. And the reason is it tells you basically there's a Readiness Probe failure, and then logs tell you essentially the same thing. Okay, so the events do. Okay, so that's expected. I think I got thrown off by using node for a minute there. Okay. The next example we're going to cover is, oh, we already did this one. This is the one we just did, right? Okay, so now actually we're going to go down to the ready example. So I think this is the last example. Oh, good. Thank goodness. So let me just look at the last example. Helm, uninstall, dev, right? And we are going to look at the last example, which is the ready case. So ready. And let's look at the diagram first. So ready, what's going to be, what we should see is the pod phase should be running. All the pod conditions will be true, right? And then, hang on a second. I think I skipped the example. Let me pause the video for a second. I skipped the example here. Okay, back. Yeah, I actually skipped the example. Maybe just getting anxious here. So this example is a subtle one, but it's the not ready example. So let's look at, there's a new thing that I introduced here. There's a new condition called cond1, right? Now what you can do is, normally there's some default conditions that already exist. That's like the pod scheduled, initialized, there is ready and container ready. Now you can define your own conditions that are custom, essentially, and which you can basically hold your container for being, not your container, your pod from being ready until it becomes true, right? So that's what essentially is called there's a thing called a pod readiness, and this is readiness gates. So let's look at the example. And what's going to happen is we'll see that the containers will become all ready, right? They'll be running, the container will be ready, ready. All the containers will be ready, so you got this green dot here. But because the custom condition is false, the pod itself will not be ready. So this is the last example of not being ready, right? Let's look at the code as an example. So if you look at not ready, and you look at the example here, so you have now essentially container, and you've got your readiness probe that's valid now, right? The initialization containers are all good, and I added this thing called a readiness gate called, now this string here, it looks like the format is like domain name / label, right? So I just called it cond1, and this is a domain I own, so I used it, right? And the trick here is when I set this, basically this pod will never be ready. And the way that you can trigger that to change is through an API call. So you basically, presumably inside of your container, you're doing some checks, and at some point you decide that, hey, that the pod is ready. Like one of the containers decides this. It can make an API call to Kubernetes, set the readiness gate on this condition, this custom condition, and say you're valid, in which case the pod will come up, right? So this kind of gives you a fine tune, and you can have more than one of these, but the idea is you can now control exactly when your pod is ready, and using something from your code, okay? So I'm not going. What I'm going to do here is I'm going to only make it fail. I'm not going to show you. I'm not going to write the code right now to show you how to flag it as being ready. Okay, that's outside the scope of this video, to be honest. So let's just run this real quick. So if I do helm install dev not ready. Okay, let's look at this now. So if I do kube control get pod, so it's running, right? But if I do kube control describe pod, okay, let's go through the whole thing. Okay, so it's running, okay. But if I look at the conditions, I will see, start at the top. Initialized, no. First thing is pod scheduled. It's initialized. The containers are ready, okay? But there's a custom, see this readiness gate here? TodosRS.com has a no status, which is essentially false, which means now, because there's a readiness gate basically not set to true, that the whole pod is not going to be ready. So that's essentially the example, right? And then in terms of everything else, you'll notice that the containers are all basically ready. Everything's good. And in terms of the error messaging, let's see if it says anything here. Now, interesting enough, there's nothing in here saying that there's an error. So how would I know? This is a super subtle one. If I look at this one is a pretty tricky one because I see nothing in here that would tell me that this is not running, other than happening to know about the readiness gate. Yeah, I just noticed that. So this one's super subtle. So again, it's under the conditions. You can see it's not ready. And then the key was you notice that this readiness gate was set. And that's why it's not actually running. It's not ready. So that one's super tricky. Okay. Then let me get rid of this one. Helm uninstall dev. And we're going to look at our last example. Finally, our last example, which is the ready state. And again, we're going to basically take out, I'm just going to get rid of that condition, right? So that's why this will run, right? So then the pod will be ready, running. All the conditions will be true, including ready now. And of course, all my containers will be, the two initializations, ones will be terminated successfully, the container will be running, and then it'll also be ready. So it's kind of like the proper state, right? So let's run this one and then inspect it, and then we're done with this video. So if I do kube control install ready, dev ready. Oh, it's not cube, it's Helm. Okay, so let me say kube control get pod. Right, it's running. Okay, it doesn't tell you a whole bunch. You have to really go to describe it before you can see everything. And the key here is you can see that the pod is running, but you can also now tell that the conditions are all true, right, including ready, because there's no extra gate, right, and which basically means everything is now, it's ready to be used. I mean, the key one is really to know that things are really looking good is when you see this ready is true. And then, of course, you can see the containers that are all in their appropriate states. Okay, that's it for this video.